All right, guys, hello and welcome. Thank you for choosing to spend the next hour with us for our webinar. Are you properly using JWTs? We appreciate you. My name is Kristen Davis. I'm head of marketing here at 42 Crunch, and today I am joined by our CTO, Phil Liata. Before we get started, just a few housekeeping items. Everyone's going to be muted during the presentation to avoid disruption. If you have any questions, please enter them into the Q&A, not the chat, but the Q&A. And we'll address as many questions as we can get to at the end of the presentation. This session is being recorded, so if you have to drop off early, don't worry. We'll make sure that we send out a follow-up email with the recording, as well as a link to a blog that'll have all the Q&A in there. So if we did miss a question on this webinar, it'll be in the blog answered in the Q&A. If you have any questions after the webinar, feel free to reach out to me directly. I can help you with those. And that was it. Short and sweet. So now let's get to why you guys are really here. I'll pass it on off to Phil.
So we're just going to talk about the JWT guys, and let's go for it. So first part will be what are JWTs or JWT tokens, and what is the crypto behind it. Okay, so first, why do we need token? Actually, we need token because we don't want to have our passwords and sensitive information go over internet and being potentially captured by anybody. So instead of sending directly the password to the API resource you're targeting in the end, we've got a dance which is called the OAuth or OpenID dance that will allow you to avoid passing your password actually over internet. So it goes like that. You've got the user connecting to the client app, and the client app will request an authentication code or whatever to the identity provider, aka ADP. And then the IDP will send a redirect so that the end user can log in against the IDP. That's what the guys do. And then afterward, the client app will receive an authorization code, and it will exchange the authorization code, against an access token. It will validate the whole stuff, and then the access token is delivered, and from that, the client app can actually retrieve the resource and then send it back to the customer. Okay, so what are JWT tokens? JWT tokens, which are defined in RFC 7519, are actually a way to convey over HTTP claims, which are key value pairs encoded in the JSON format, that might ease actually the communication between different parties in the IT system. So these claims in a JWT are encoded as JSON objects, and this JSON object is used as the payload of the JSON Web signature, JWT structure. And this is actually where the crypto comes into the play. JWT are easy to use, supported by a lot of libraries in a lot of languages, and so it's really easy to use, and that's why they are pervasive. Tokens by themselves can be anything. I mean, a token is a piece of information, so it can be or a handle to some information, meaning it's an opaque token, And when you use this token, you can retrieve actually the token and ask somebody to tell you the information that is behind this token, or it can be a self-contained token like a JWT token, which is containing actually all the information that you need to proceed the request. So why do we need JWT tokens? Because all the information that you need to proceed the request is actually contained directly in the token. So once again, you've got the difference between handles and self-contained tokens. And a JWT token is actually a self-contained token in which you've got everything that you need to proceed actually the call. So you don't need no shared database, you don't need no extra API calls, and everything is actually contained in the token. And for each and every request come in, you will find all the information needed to proceed the request, to process the request. Okay. And JSON is so easy actually to use in the modern languages codes. So the common use cases for JWT tokens are OAuth 2.0 and OpenID Connect and any JSON payload that needs to be protected and sent, meaning that actually access tokens in the OAuth 2.0 and in OpenID Connect can be or an opaque token, as I said, a handle that you will need to dereference against an identity provider, or they can be directly JWT token containing all the information that you need to process the request that has been sent by the user. So this is all what is IAM related, but there is another great use case, which is actually when you need to exchange some information between a client and an API. You've got two ways of protecting stuff. So, or you rely on the transport level protection mechanisms, like TLS, for instance, which is good, but not enough for a bunch of reasons. Or you can ask your provider to put in place message level encryption and signature, so that at the message level, everything will be protected. And so once again, JWT is a perfect thing for that. So you've got message level protection, cryptographic protection of the that data that must be exchanged. Okay, so tokens are normally encoded. So tokens will be passed actually in the URLs or the HTTP headers. They will be base64 encoded, but be aware that base64 URL encoding is not signing and it's not encryption. Actually, it's just an encoding, so you can decode it perfectly. So if anybody does man in the middle, they will be able to decode everything that you see and send. So how would you know that a specific token is coming from a specific source? Well, tokens should be signed and encrypted, meaning that you should be able to verify that the guy that emitted the token is the proper guy, actually. So because you know that the guy that signed the token has private key corresponding to a public key, and the public key was used to sign the token. So you know that the guy is the guy that signed the token. Okay. And in authentication scenarios, the IDP signed the new token. They calculate the structure, the appendix to the token, and then afterward, the client pass the token to the resources as it is. And then, and this is really very important, the resource must verify the signature to be sure that the token has been emitted by who should emit it. Okay. So JWT tokens are actually a JWS, so JSON Web Signature structure that has been encoded in using base64 URL encoding. And in this structure, you will find first a JWT header. So I don't know if you're familiar with the JWS stuff, but in the JSON Web Signature, more or less, you've got a header which gives some metadata about what has been signed and how it has been signed. And then you've got the body that has been signed. And in the end, you've got the signature. And in the header, you will find a bunch of information saying how it has been signed and what has been signed, and how you can verify that what has been signed by who you trust. So in this JWT header, you will find an ALG entry, which specify which algorithm was used to sign. You will find a potential ENC entry if the body has been encrypted, and the ENC will be the key encryption algorithm used when using encryption, meaning that actually if you use encryption, basically, not to get into more details, but well, more or less you've got a key with which you are going to encrypt. So you get the key, you derive the key, you encrypt the key, and with the encrypted key, you will encrypt the body of it. And so you've got, when you're on the other side, you must get the encrypted key. You must get the decryption encryption key, and then decrypt the key, and then you will be able to decrypt the body, more or less. It's a little bit like TLS. TLS is working just the same, actually. And then afterward, in the JWT header, you find a bunch of stuff that are related to how you can retrieve the keys used to sign and/or encrypt, and how you can have trust to them. And that is very important. Trust is very important. So you've got the GKU stuff. So GKU is actually an URI where you can find all the JSON encoded public keys using the JKS format. You can have a JW key where the key will be provided just as is. You can find key ID, which will be just a logical ID that will help you to retrieve from that the key that was used to encrypt/sign the JWT. You can have a X5U, X5C, X5T, F5T, hash S256. Well, all this is actually how you can retrieve the key that was used to sign and/or encrypt the JWT that you have to work with. Knowing that, once again, all this is based on the trust, meaning that, well, I will talk about that later on. Okay. So the signing process, you have to create a JWT header. In the JWT header, you will find actually the signing algorithm, the optional encryption algorithm, if you encrypt the JWT, and reference to the key. Okay. Then you have to encode this JSON header, and then you've got your payloads. You encode, you base64 URL encode the payload. You can get all this with dots, and then you sign that, meaning that you take a hash of it, and then you encrypt it with your or symmetric key or asymmetric key, and then this gives you a signature. You base64 encode the signature, and then you append it to the rest, and that's it. You're done with actually your JWT signing process. Okay, and so this is actually how a JWT token works. But once you got a JWT token, which is signed and in some rare cases encrypted, what would you do with it? And also, what should you do with it? And what should you look after, excuse me, in terms of attacking of the JWT token? So there are a bunch of attacks that are actually described over the internet. So the first attack is the non-algorithm attack. So the stuff is that, okay, you've got a JWT token. Here on the right side of the slide, we see a base64 URL decoded JWT token. And so you can see that, okay, there is an ALG stuff and a JWT type and a body that is the body that is signed actually at the moment. And what we're going to do, we're just going to change the algorithm to known, meaning that there is no signature at all, and that's it. And what are we going to do? People will just use that as a non-algorithm JWT, and if your JWT stack is not protected against that, or if you did not parametered your JWT stack to not accept that, well, it will just accept it, definitely. Then we've got the HMark algorithm attack. So what's happening there? So actually, you are going to use an asymmetric signature to protect your JWT token, meaning that you've got your token, you've got this user is-admin file stuff to be protected, you sign it using your private key, and then you pass the public key in your JWT token. And the attacker is going to just take that, change the body, so from user Elmer Footbit to Elmer Footbit and is-admin true, and it's going to sign it using actually HMark algorithm, so symmetric algorithm mechanism, but using the value of the RSA public key as the symmetric key. So once this is done, it will send that to you, and you trust the key because it's trusted, and you verify the signature, and the signature is okay because it's been signed with the public key, and the public key, well, it's okay. So you will accept that, and that's bad. So this problem is actually solved by the fact that normally you should never store a cryptographic key without specifying which algorithms are supposed to be used with this specific cryptographic key. So lack of signature validation, this is not the problem actually. If you don't use out of the box and framework related cryptographic mechanisms, it means that you will have your developers to implement signature validation, decryption and everything. And this is bad. You should never do that actually. Because in the end, what we'll see is that a lot of times developers just don't do the proper stuff. And I remember in the year 2018, there was an inventory on the Android Play Store stuff. And so they tried to have a look at what was implemented properly in the Android Play Store. And they figured out that actually something like 40 or 50% of the Android Play Store applications were just not properly validating signatures. So yeah, this is a huge problem. So don't rely on your developers to validate signature and decrypt stuff. Please use proper stuff. Okay, so brute force attack on signature. This is another stuff. So once again, this is a must in the RFC, saying that if you want to use a shared secret, it must have to have something like 128 bits of entropy, but this is not always the case. And so this is something that you really should look after, actually. If your entropy is not good enough, you know that you will be broken soon. So brute force attack on signature, this is for HMark, symmetric signature stuff. So the point is that, well, your JWT token has been signed. Okay, it's been signed by a symmetric secret. So you will try to brute force directly the secrets. And as soon as you are able to intercept a JWT token, then you can take it and offline try to brute force it. And when you manage to brute force it, well, in the end, you've got the signing key. And with that, you are able to impersonate the proper key owner. So this is really important. So in the specs, once again, it said that you must not use human readable secrets, and you must use secrets with an entropy other than more than 128 bits. Sorry. Okay, leaked keys. This is a trendy problem. So at the moment, we all know that actually there are a bunch of bots running against GitHub, GitLab, and everything. So there are a lot of open stuff there, and we are able to run these APIs and retrieve a bunch of information about what is stored in these GitHub and GitLab's repositories. And from that, it's believe me, it's very, very easy to build a script that will download a bunch of files from GitHub, GitLab, and then from these files, try to find out what looks like an API key. So once the guy has got an API key, well, it will try it, and that's it. He owns you directly. So you should never store an API key in GitHub or GitLab. Said like that, it seems obvious, but in the end, we are sure that it happens. So please make sure that this is not the case in your organization. Oh, this one is a nice one. So, oops, sorry for that. So the point is that when you reference actually a key in your JWT header, you've got a key ID reference. And the key ID reference can actually be, it should not be, but it might be, actually a file path for the key in some cases, which is not something that you should do, but we can find that in the wild. And if you do, well, for people who do that, actually, it's very, very easy to change that and to use path transversal attacks that will actually let you, the attacker, put some stuff in some files that were not intended to be used actually for the for these keys. And so, yeah, that's one attack. And we got more or less the same with a SQL injection. Oop. So the same here. So in the key ID stuff, you will give some value, and in an unsafe SQL retrieval, you will use directly the key ID using some stuff like select key where key equals $key ID. And if in the key ID you've got some stuff like blah, union, select, key, blah, blah, and comment, well, you will pass. So, yeah. So once again, you must be very cautious when it comes to using the key ID mechanism. Okay. And you've got, again, the same stuff with the common injection in the key ID stuff. Okay, this guy is a different guy. So, substitution attack. And this is a problem which leads to a bunch, actually, of reflection in the OAuth and OpenID Connect community at the moment. So, problem is that an attacker can get a valid token for one organization resource because he owns it. So he can ask some guy to give him the ability to consume some stuff because he's from one organization. And then he will try to use the token that he obtained to consume some resources that are dedicated to other organizations / guys. And it's a really big problem because actually, once again, all the OAuth and OpenID Connect specifications are based on what we call bearer tokens, meaning that as soon as you get a token, you are able to consume a bunch of stuff. So this guy is just, I got a bearer token, I'm trying to consume some resources that were not, that are not in my scope. This is the first part of the problem, actually. I will talk about the second part of the problem just after. So, to prevent from that, actually, you must make sure that what the resource is requested with an access token is just matching what the resources scope was given by your identity provider when the guy requested the access token. Meaning that if some guy requests some access token, he will have to say, okay, I request an access token to do this and that on my stuff. And then you give him the access token, the JWT token, and then he will use the JWT token to try to access to some other stuff and do some other thing. And you should be able to say, no, that's not possible. The JWT token that I generated was to do this and that, and you're trying to do some other stuff on some other data. And you must be able to spot that. And yeah, things have changed actually. Previously, we were in an MVC world. So you had model, view, and controller, and the controller was in charge of actually checking that this guy requesting this action on this data was allowed to do that. This control layer has more or less disappeared. Not completely disappeared, but it's no more actually in the frameworks, which means that you must re-implement it at the backend level. You must do that, and really it's a must, because otherwise we got all the problems that we're facing today with people connecting, authenticating, retrieving access token, and then they are able to try to do anything on any ID, object IDs, and this is scary, definitely. This is a huge problem today with the OAuth and OpenID Connect ecosystem. There is no longer, by default, check that what you're trying to do, you're allowed to do it. So you must implement it at the backend level. Okay, another attack is the cross JWT, and it's more or less the same stuff. So you're just retrieving a JWT token, and from that, you're trying to address another organization. Well, not another organization, but you connect to an IDP, you retrieve some JWT token that should be allowing you to do some stuff on this and that resource, and there is a lack of check on the resource, and it will allow you to actually consume some other resources that you should not have access to. So there are quite a few stuff. Auth0 was broken with that a couple of years ago, for instance, and the story is nice. You can find that on Google. No problem. But the point is that, there is a lack of exact matching with the audience claim in the JWT token. So precisely, if you don't check that there is a perfect match between the requested audience and the target audience, then you are open to these kind of problems. So, and once again, this is a must in the OpenID Connect RFC, for instance. You must have a perfect match for the audience stuff. Okay. So this is another one. So where you will be able actually to steal a token and reuse it. So basically, some guy connects to an authorization server, gets a token, and then he's able to consume a provider, okay? And then you are able to steal the token that the guy retrieved, and so you can use it and make you look like just like the guy and consume all what he can consume. So this is a huge problem with OAuth because once again, OAuth is based on the bearer token paradigm, meaning that you get a token, and if you got a token, you can do whatever the token gives you the ability to do. And this is bad. So there are quite a few initiatives actually in the OAuth world to be able to limit that. It's all related to what they call token binding. So the idea is to be able to bind an access token to who it was delivered to. So you've got actually at the moment 3 different initiatives to do that. So there is one stuff called MTLS, meaning that you require the clients to have a client certificate, and then, well, you're sure that you emitted this access token for the guy who had this client private key, and it's easy. And then you've got this token binding initiative, where actually when you connect to an authorization server the first time, then you generate a bunch of transient key pairs, and you will use these RSA key pairs to communicate with the authorization server. And then when you get an access token and you send it, you sign it with your temporary private keys, and the resource server receiving the access token should be able to verify that you signed it with a private key that was generated and associated to a public key recorded at the authorization server level. So this is token binding. And then you've got a more generic stuff that is called proof of possession, which is more or less an abstraction layer on top of that, saying how this could be put in place. But yeah, the ability to bind an access token to the guy that really did receive this token is something that is an ongoing problem, and it's not solved at the moment at all. And yeah, it's nice to see that it's well, people are still working on that. And we at 42 Crunch have a bunch of answers to that. Just to say, this is the only 42 Crunch stuff that I will say I will tell about. Sorry for that. Okay. Yep. Another big problem is that actually tokens are not opaque. Well, they may not be opaque. So JWT tokens can be, as I said, or signed or encrypted. And if they are encrypted, they are also signed, because JWT encryption uses authenticated encryption mechanisms, meaning that you've got at the same time when you encrypt, you sign, more or less, to say this, the thing easily. But there are not a lot of people using encryption for JWT tokens. It's mainly, say, 98%. It's just signature. And so when you deal with just signed JWT tokens and not encrypted, well, for sure, these tokens are not opaque, meaning that everybody can see what is in the token. So if you put some sensitive information in the token and you don't encrypt it, well, everybody that can do man in the middle will be able to get the token, basically for URL decode it, and retrieve all the information that is in the body of the JWT token. So if you put some PII in it, like if you put in place OpenID Connect, for instance, the ID token will contain a bunch of PII about the end user. So yeah, that's it. And you must be aware of that, and you must take care of that, definitely. So the first solution for that is to be to use actually encryption. So if you got some PII information to embed in the JWT token, and if it has to go outside of the network that you control, then you should, and even you must, encrypt it. Okay. If you do that, well, you will find this enc parameter in the JWT header we just talked about previously, and that's it. And just to say a few words about the structure of an encoded JWT token. So if you remember well, in the signed JWT token, you've got just 3 parts: the JWT header, and then the what you sign, and then the signature. If you encrypt it, you will find 5 different stuff. So you will have the JWT header, you will have the JWE encrypted key, you will find an IV, you will find the ciphertext, which is actually the encrypted payload, and then afterward you've got some, this is called authentication tag, but it's additional authentication tag, to be accurate. Okay. So tokens are not opaque. Yeah, this is just what I was talking about. Everybody can actually decode, well, everybody that can do man in the middle or retrieve the token offline is able to decode the token and get PII from it. Oh, okay, so phantom tokens. This is a very interesting solution, actually. So the goal here is that you might have some interest to use JWT token inside your infrastructure, meaning that you are using a bunch of microservices and you want to put in place zero trust network, in-depth defense, whatever, meaning that you have to have at each and every step the validation of the JWT token that is sent with the request. And okay, so that's good. You've got this inside your microservices infrastructure, and you make sure that when a request comes from any microservice to any other microservice, it comes with a JWT token that you are able to validate properly, and that's it. So you're sure of the identity of the end user that did trigger the request that you're processing. So that's cool. But once again, as we just said before, these JWT token contains some PII that you just don't want to expose to everybody. So this PII should not go out in the internet. And one good framework to do that, one good solution, is to use what is called phantom tokens, meaning that actually you will use an opaque token over internet between the client and some entity that will stay at the edge of your network. And when a request comes, you will exchange this opaque token against the JWT token corresponding to it, and then pass the request with the JWT token to the rest of your infrastructure. So that's, you've got the best of two worlds. You've got all the information needed that is passed to your microservices, and you do all the validation needed at your microservices level, and you're sure that you protect your microservices properly, and you're sure that your east-west communication is properly protected. But in the same time, you know that there is no PII going out of your IT over internet. So that's a great, actually, paradigm. So that's it. Blah, 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 blah. Okay, patterns and anti-patterns. So this one is really important. Don't use JWT to handle sessions. This is bad, definitely bad. I mean, at least when you deal with web browser-based applications. If you deal with mobile application, well, you got no choice. But as soon as you're able to handle cookies, don't use JWT to handle sessions. It's not done for that, definitely not, for a bunch of reasons. The first reason is that there is a session mechanism for web-based and compatible HTTP, RFC, I don't remember the number, the cookie RFC, HTTP, that work properly. And actually, we've been spending years and years actually to make the cookie handling better and better at the web browser level. And so we got a lot of protections, and there is no interest into removing all this stuff mechanism that works pretty well, that is pretty well protected with a bunch of protection at browser level, just to use a JWT token that contains everything, and if stolen, that can be used to impersonate you and do whatever on some other stuff. So what is sure that cookies are properly protected today, really, more and more. And if you use JWT tokens as a cookie, as a session mechanism, you've got all the risk that they will be stolen because it will be easy. They are not protecting you against, I don't know, web browser cache spoofing or, well, whatever. So it's really better to use cookies than JWT to handle sessions, definitely. Oop. Okay, another recommendation is when we talk about share secrets and more generally, when we talk about keys. So shared secrets, they should be the most complex possible. Once again, in the RFCs, you've got a bunch of recommendations, a bunch of must that you should respect about the minimum entropy that a key must comply to. And that's it. And then more generally, talking about keys, keys must be safely stored and retrieved, meaning that you have to have a key store. And in this key store, all the keys that you list must be used for one and only one algorithm. And this is a must, once again, in the RFCs. So if you store a key, you you have to use it for once and once only algorithm. So if we're talking about signature, for instance, if you store an RSA key, well, you will say, okay, I store this RSA public/private key, and I will use it to sign only using the, I don't know, PS256 algorithm. So that when something is signed and you receive it, you can check that the algorithm signature is corresponding to what is stored at your key level. And you're sure that nobody is trying to do some other stuff, actually. And once again, it's a must in the RFC. So the key store mechanisms have to change. And nobody is doing that at the moment. We are working on it, but yeah. We will have to move to key stores where when you upload the key, you will have to say, okay, this key has to be used for this and this only algorithm. This just does not exist at the moment. We're just working on it. Blah, 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 blah. Okay. So some overall recommendations. Keep external tokens opaque. Okay. So this is the phantom token stuff. So external token or encrypted token outside, and in the inside, then you can use JWT or unencrypted JWT tokens. Okay. So some token validation recommendations, and this is fairly important. So follow standards for all claims and processes. So please follow the RFC. If you go and have a look at RFC 7519, the JWT RFC, there is a validation, token validation entry in which there is something like 9 or 10 different stuff to be done when you want to validate a JWT token. And each of these are really important. It's the vital minimum stuff that you must do. It's not enough, but you must do it. And then afterward, you can add some extra checks. But all the claims, well, first you must ensure that it's a proper, well, you must basically for URL decode it, check that there are 2 or 5 points in it. And then if it's 2, it's a signed JWT token. If it's 5 points, then it's an encrypted JWT token, in which case you turn to a validation scenario. So if it's a signed token, which is once again 99% of the JWT tokens you will have to deal with, you must basically for URL decode that. Okay, make sure that the first part is a proper JSON header. Make sure that the second part is a proper JSON claim sets, and the third part, well, at the moment we don't care. Well, you know, it's all this, and all this is precisely described in RFC 7519. So you have to do that. And then when it gets to the body itself of the JWT token, in the JWT token, you've got a bunch of standard claims, none of which are mandatory. But for each and every standard claim, if they are present, then they got a semantic, and you must validate the semantic of it. So there are stuff like the issue time, the expiration time, the JTI, the identifier of your JSON Web token. So yeah, there are a bunch of stuff to be done like that. You must be sure that the JWT you're working on uses an expected algorithm. So don't let anybody uses whatever key and whatever algorithm to build up a JWT that you will consume. If you want to use JWT, you have to say, okay, you will have to use this and that type of key and use this algorithm. And if you don't use that, get lost. I will just not accept you. Then once you're sure of the key, oh yeah, there's something missing here. You must check the trust that you can make to the key that was used to sign the JWT token that you're consuming. So, but this is another couple of hours discussion, but checking, well, making sure that you can trust the key is something absolutely essential in the process of the validation of your JWT token. It's between 2 or 3. But once again, I don't get time enough to talk about that. So yeah, when you're done with that, you've got to validate all the cryptographic stuff. So you know that you accept the algorithm, you know that you trust the key, and so you can now validate the cryptographic operation. Okay. And then you will have to validate the issuer and the subject. So once again, remember, there were some attacks about that. Non-specific enough issuer and subject stuff, and the same for audience. So there are definitely some attacks in the wild about that, using you know, star or regex-based stuff instead of a perfect match. So this is not good at all. So if you can not use that, please don't use that, because it's an open door to a lot of problems. And do not trust by default claims, meaning that you should be able to constrain the value of the custom claims that your JWT is containing. Because otherwise, yeah, you can have a bunch of problems, injection and whatever. So, sorry, I'm running very, very late. So I'm going to try to speed up myself. Okay, so how can we describe that? So at the moment, there is not much done. Actually, in OpenAPI, there is nothing to describe JWT, how you should build up your JWT so that it can be consumed by the server, by the API backends. We're just working on that at the moment. So we are part at 40 Crunch of the OpenAPI initiative, and we are proposing at the moment a bunch of extensions that will allow for describing the requirements for JWT directly in the OpenAPI file. Okay, and this is something completely different. This is server-side, but it's related really to our product. So maybe I can just say a word about that, but I don't like it that much. We got a product that is able to filter out all what is coming into an OpenAPI based API. And in this product, we're able to say a bunch of stuff about JWT. But once again, this is really specific to us, and I don't want to talk about that. Okay, and I'm more or less done. You got some question, guys? Christine?
All right, thanks. So we have a couple questions.
Cool.
The first one is it considered safe if the JWT token is validated within the ASP.NET Core itself with every request? Like when it's set up within the construct of startup.cs and every single controller action is marked with the authorized attribute?
Sorry, I'm going to ask you to repeat, please.
You can see the questions.
Yeah. No.
Click on Q&A at the bottom, because I may not be reading it right.
Yeah, but no, I just can see it. Sorry for that. Yeah, it's Q and R. It's French.
Oh.
That's why. Okay, JWT and validating with the ASP.NET Core itself with the, yeah, you should do that, definitely.
Were you just speaking in French?
Yeah.
The next one, in this presentation, the JWT are used as mechanisms to identify who is in the request and for identifying what is making the request. I'm not sure what's being asked there.
Yeah. That's a proper question. It's because actually in Auth and OpenID Connect, you've got you've got the end user, you, Christine, you've got the application, your application in your web browser, for instance, and then you've got the resource server. So you've got the client, which is the application, you've got the resource owner, that is you, and you've got the resource server, that is the API. And so the guy is asking if the JWT identity, is it the end user or is it the client? Well, it depends. By default, if you use a mechanism like OpenID Connect, it will be the end user. But if you use an OAuth mechanism using, I don't know, client credentials, it will be the client. So it depends. Sorry, I cannot be more specific because both are possible, actually. It depends on the case.
Okay. So the next question is it a good idea to expose invalid parts of the JWT? For example, I could expose that the issuer is invalid.
Yeah, I've seen that. So I don't know exactly what Thomas means by that. I'm trying to think at the moment, but I don't know what he means by invalid parts of the JWT token, actually. I don't know. I just cannot answer that, actually.
Okay. Is it worth it to use 384 or 512 over 256?
No, we don't care. Actually, 256 is really, till we got some quantic processing, 256 is really okay for something like 15 years, I guess.
I had no idea what that one meant. A bunch of numbers. Next one, is it better if I use OAuth 2 to send a token to the client in JWT to send the info to my microservices?
Yeah, definitely. Definitely. It's what we are advocating for. And not us only, but a bunch of people. Yep. Mm-hmm.
All right, great. That's all the time we have for questions. If we did not get to any of your questions, we will answer those in the blog. Also, if you get off this webinar and you think of something, feel free to reach out to me personally. My personal email or my work email address should be on the invite. And Phil, do you have any closing remarks?
No, sorry for my bad English, but I'm
I can understand
English speaker. So sorry for that. Sorry for that.
Oh, you're fine. Thank you all so much for joining us, and I hope you join us on our next webinar. Look for a follow-up email that'll either come tomorrow or Monday. We look forward to seeing you again.
Thank you so much.